Oh, thanks for that report, Alfred. Hello everyone, I'm Queenie Rodriguez. Moving on, let's tackle nanomanufacturing, the bottom-up fabrication and top-down fabrication. So, when we say bottom-up fabrication, this offers the potential for precise control over the structure and properties of materials. It can indeed be time-consuming, especially for complex structures or large-scale production. However, it can result in highly customized and precisely engineered materials with unique properties not achievable through other methods. While top-down fabrication can achieve precise control over the final product, it often requires larger amounts of starting materials and generate excess waste due to the removal of material. Despite these challenges, the top-down fabrication remains a widely used approach in nanotechnology for producing various devices and structures with specific dimensions and properties. So, that's all for my part. Let me call on Reporter Shine to further discuss about the new approaches to the assembly of nanomaterials based from the application of principles of and top-down and bottom-up fabrication. It's your time to shine, Miss Shine.
So thank you, Reporter Queenie. So hi everyone, good morning. I am Shine Kimi Casquejo. And to continue further with our discussion, there are new approaches to the assembly of nanomaterials based on the application of principles in top-down and bottom-up fabrication. And it includes first the dip pen lithography. So dip pen lithography is a method in which the tip of an atomic force microscope is dipped into a chemical fluid and then utilized to write on a surface like an old-fashioned ink pen into paper. So dip pen lithography is a direct write lithographic technique that uses an atomic force microscope to build a pattern. It's like using a fountain pen to draw with molecules, and these molecules are delivered from the atomic force microscope to transport, and making dip pen lithography a potentially useful tool for creating and functionalizing nanoscale devices. So, in other words, dip pen lithography can be used in a range of applications from semiconductor patterning and chip manufacturing to biomedical and pharmaceuticals development. Next is we have here the self-assembly. So, self-assembly depicts an approach wherein a set of components join together to mold an organized structure in the absence of an outside direction. So, while ang katong dip pen lithography is nag-use yung atomic force microscope to build a pattern, ang kaning self-assembly is the molecular arrangement of the disordered entities of molecules into highly ordered structures or patterns resulting from the interactions among the components themselves. So, in a simple word kay, ang kaning self-assembly is mauni siya ang makaform og iyahang nga pattern without the need of human intervention. So, next is the nano-imprint lithography. So, nano-imprint lithography is a method of generating nanoscale attributes by stamping or printing them onto a surface. So, unlike traditionally optical lithographic approaches which create patterns through the use of molecules, nano-imprint lithography is a high-resolution lithography technique used in nanotechnology to fabricate nanoscale patterns and structures on various substrates. So, nano-imprint lithography is nag-rely siya sa mga direct mechanical deformation and can therefore achieve resolutions beyond sa limitation nga giset sa light diffraction nga ma-encountered sa mga conventional lithographic techniques. Okay, so next is the molecular beam epitaxy. So, it is one manner for depositing extremely controlled thin films. So, molecular beam epitaxy is an epitaxial process by which growth of material takes place under UHV conditions, and it also allows for the growth of thin films of various materials with extremely high purity and accuracy. So, Ang kaning molecular beam epitaxy kay mao ni siya ang technique nga giuse sa fabrication of sa mga semiconductor materials and mga devices nga with precise control over thickness and composition by the interaction sa mga absorbed species nga gisupply gikan sa atomic or molecular beams. So, next is we have here the roll-to-roll processing. So, roll-to-roll processing is a high-volume practice for constructing nanoscale devices on a roll of ultra-thin plastic or metal. So, roll-to-roll processing in the field of electronic devices is also known as a web processing, and it is a process of creating electronic devices on a roll of flexible plastic, metal foil, or flexible glass. So, roll-to-roll processing is mao ni siya ang high throughput manufacturing technique nga giuse sa nanotechnology to fabricate flexible electronics, energy devices, and mga other nanoscale devices and materials. Lastly is the atomic layer epitaxy. So it is a means for laying down one atom thick layers on a surface. So atomic layer epitaxy is also known as an atomic layer deposition. That's a technique for growing thin films for a wide range of application and precise growth of materials at the atomic level. So atomic layer epitaxy is it also works by sa mga sequentially depositing ang mga individual by atomic layers into a substrate surface, and it also offers excellent control over sa mga film thickness and composition, making it ideal for fabricating nanoscale devices with high precision and uniformity. So I believe that's all for my part. So now let's hear from the next reporter. Reporter Julysa, the virtual floor is now all yours. Thanks.
So thank you so much, Shiny. So hello everyone, maayong buntag, Julysa here. So let's moving on. Let's have the discussion about distinct features of nanoscale. So distinct features of nanoscales that nanotechnology like involves of operating at a very small dimension, and it allows to scientists to make use of the exceptional optical, for chemical, physical, mechanical, and for biological qualities of materials of that small scale. So there are three following distinct features of nanoscales. So first is scale at which much biology occurs. So various activities of the cell take place at the nanoscale. So the DNA serves as the generic material of the cell and is only 2 nanometers in diameters. So these scales not encompass of molecular interaction, circular process, organismal behavior, and population dynamics and ecological interaction. So each skills can provide unique insight into biological phenomena and contributing to our understanding of life complexity. So from molecules and scales to organism and ecosystem. So the second one is scale at which quantum effects dominant properties of materials. So quantum effects direct the behavior and properties in this size scale. So the quantum effects dominate kay kanang the properties of the materials kay at the atomic and subatomic scale. So di kani nga effects kay become significant kung ang size of the materials kay mo approaches or falls below the characteristics length, skills kay mo associate with quantum phenomena.
Then, and lastly is nanoscale. So, nanoscale materials have far larger surface areas than similar masses of larger scales materials. So, as the increase the surface area per mass of a particular material, a greater amount of the material comes in contact with another material and can affect its creativity. So, exactly, kung ang materials mo reduce to the nanoscale, so ang surface area to volume ratio mo increase po siya dramatically compared sa kanang larger scales counterparts. So this kay enhance a surface area has a profound implications for various properties and applications. So such as mo increase ang reactivity, so mo improve pod ang catalytic activity and mo enhance pod ang mechanical strength sa nanomaterials. So that will be all my part. So now let's welcome to the next reporter, J. Marie Baso.